Welcome to this lecture on Azure Virtual Network, which is the foundation of your network architecture in the cloud. Imagine you're building your own private data center, but instead of racks and routers, you're using software-defined infrastructure in the cloud. That's exactly what a virtual network offers you. A secure, isolated environment where you can run your Azure resources like virtual machines, databases, app services, and more, just like you would on premises. In simple terms, an Azure Virtual Network is your private cloud network within Azure. Think of it as your cloud-based local area network. It gives you isolation from other tenants in Azure, control over your IP addressing, DNS, routing and security policies, and connectivity to on-premises networks, other VNets, or the internet. You get to define your own address space using private IP ranges, which is defined in RFC 1918, and within that space, you can carve out subnets to segment workloads. Once you've got your VNet, the next step is subnetting, just like you do in traditional networks. Subnets let you divide your VNet into smaller manageable sections. Why? Because segmentation brings control and security. You can isolate front-end VMs from back-end databases or group resources with similar security and performance needs. Each subnet is associated with a portion of the IP address range of the VNet. Network security groups to allow or deny traffic, route tables to customize how traffic flows, and service endpoints or private endpoints for secure access to Azure services. When you start working with Azure Virtual Networks, you're stepping into a world of powerful capabilities that let you build a secure, connected and flexible environment for your cloud resources. Inside your VNet, your resources can talk to each other privately using Azure's global backbone. No need to expose them to the public internet unless you choose to. Outbound internet access is enabled by default, so your VMs can reach out for updates or downloads, but they won't accept inbound traffic unless you explicitly configure a public IP, load balancer, or net gateway. You also have full control over how traffic flows within and between your networks. By using user-defined routes, you can steer traffic through specific paths, like routing all traffic through a firewall or a custom network appliance. If you want to integrate Azure services directly into your network, you can use service endpoints to allow secure connections to services like Azure Storage and SQL over the backbone. For even more isolation, private endpoints let you assign private IPs from your subnet to those services, keeping traffic fully contained within your VNet. Connectivity beyond Azure is just as flexible. You can connect your on-premises data center to your VNet using a site-to-site VPN over IPsec, or go with Express Route for a private high-bandwidth connection. If you are working across multiple VNets, whether in the same region or across different ones, VNet peering lets you link them seamlessly with low latency and high throughput. For security, you are in the driver's seat. With network security groups, you can control what traffic is allowed in or out of your subnets or even individual virtual machines. If you want to go further, then combine NSGs with Azure Firewall, DDoS protection, and application security groups to build layered defenses. And if your organization uses third-party appliances like Palo Alto or Fortinet, you can deploy those as network virtual appliances right into your subnet and use custom routes to direct traffic through them. In short, Azure VNets give you the blueprint and the tools to build a network that's secure, scalable, and tailored to your architecture. You're not just using the cloud, you're shaping it. Imagine you're deploying a 3-tier web application in Azure. You begin by creating a virtual network with an address space like 10.0.0.0/16, giving you plenty of room to carve out subnets for each layer of your application. You then divide this space into three subnets. One for the web front end at 10.0.0.1.0/24, another for the application logic at 10.0.0.2.0/24, and a third for the database layer at 10.0.0.3.0/24. To secure your design, you apply network security groups so that only the web subnet can receive traffic from the internet, while communication between the app and database tier is tightly controlled. For extra protection and privacy, you set up private endpoints in the database subnet, allowing your SQL server to be accessed securely without ever going through the public internet. And to ensure high availability and disaster recovery, you use VNet peering to connect this environment to another VNet in a different Azure region. With this setup, you built a secure, segmented, and highly available architecture for your web app. So, what's your key takeaway? Azure VNets are the foundation of networking in Azure, offering full control, isolation, and security. Subnets let you logically segment your network and apply custom security and routing. With service endpoints, private endpoints, VPN, peering, and express route, you can securely connect almost anything. You are not just lifting and shifting into the cloud. You are building an intelligent, scalable, and secure network that grows with your business.